All right, time to go through one more part of our slope presentation, slope field presentation, and that is given a differential equation and a specific condition, such as f of 2 equals 3 or something like that. We can actually find or estimate values of a solution to that differential equation, or we could write tangent lines to that differential equation. So we're just going to go through some examples of what that looks like, starting right here. Let me turn on a pen real quick. We'll go to green. All right, so first of all, sketching this, I'm not going to spend a lot of time since we did that in another video, but basically we're putting in at 0, 0, x is 0, y is 0. You multiply 0 times 0, 0, divided by 2 is 0. You get a slope right there. On an AP test, you will be expected to graph that, make it very obvious, make sure it shows over the x-axis so they can see that. And if you notice on all of the values where x or y is 0, you're going to get an answer of 0. So you're going to get zeros here on the x-axis because all the y values are 0. And you're going to get it on the y-axis because all the x values are 0. So that's a quick way to get a bunch of points in real fast. And then you're just picking other points. I'm not going to go through the whole thing. I'll do maybe 1 point. We'll do -1 and 2. Okay, if I do -1, 2, then I'm going to multiply x times y on the top. So we're going to get -2 in the numerator, and we're going to get 2 in the denominator, and we are going to get an answer of -1. So I have a slope at -1, 2, which is right there, of -1. So it looks like that. Now you're going to fill in this whole thing. The next page will have the answers on there. So instead of wasting a lot of time, I'm going to just start moving into the other problems. Letter B, if f of x satisfies dy over dx, which is this equation right here. They're talking about f being the original equation. This is the derivative of this equation. Write the equation of a tangent line of f through 1, 1. So basically they're saying write the equation through 1, 1 of the tangent line, which is the slope of f of x, which we already have. All you need to do is plug 1, 1 into that equation, and that's what I'm going to do. So my slope of my tangent line is going to be me plugging in 1, 1 into this equation. It's 1 times 1 over 2. That was easy. So my slope is 1/2. And I'm already given a point, so all I need to do to write my tangent line is y equals the slope. We're going to use a variation of the point slope formula. I like to think of it as a transformation. We're going to be shifting our graph off of 0, 0. We're going to be moving 1 to the right and 1 up to get to that point. So x minus 1. Ooh, that's a parentheses. That is an ugly parentheses, but it is a parentheses nonetheless. So 1 right and 1 up, there's my tangent line. Not so bad. Well, if I can actually highlight it. All right, and then estimate 1.2. All you are going to do is go to that tangent line, yikes, and you're going to insert 1.2 into the tangent equation. So 1/2 times 1. I'm not good at writing these numbers. 1.2 minus 1. I don't know why I keep doing that. Plus 1. That's beautiful. And that's going to give you an answer of 1.1. And that's that. So we can estimate the value of 1.2 at, what is it, 1, 1? Yeah, right here. Based off of its slope, we can estimate the value to be 1.1. Pretty neat. And I'll have the answers on the next page, and here they are. Oh my goodness, it's exactly what I talked about. Just a lot more points here that are pretty cool to look at. These are the answers. You'll see all these 0 x and y axis had 0 slopes, like I said. And you'll notice that 1, 1, which is right here, it does have that slope. It's not 1, but it's like a half of 1. It's 1/2. And down here, the slopes changes. I talked about this in another video, but everywhere along here at different points, the slopes change. So if I asked you to estimate these points, 1, 1, I could ask at 1, 2, at 2, 0, at 3, 2. They're going to be different depending on where I go. And we'll talk about that in a little bit. So here's the fun part. We get to do some calculus here. It says find the particular solution if f of 1 is 1. What this tells you is it's basically telling you you are going to have to find a c value for your integral to do that problem. And you're going to use 1, 1 to do it. But particular solutions basically are telling you solve this differential equation. So we're going to get dy and y and dx and x together, and we're going to solve. And basically, when we're done solving, we're going to use 1.2 to see what it actually comes out to be. This is going to be a better answer than what we had on the last part. D and E is going to basically tell us to compare the answers we got for this problem and the answer we just got, which was 1.1, and see if the answer 1.1 was an over or under estimate, and how we could tell by using the slope field itself. And we'll talk about how to do that. So here's the answer to part C. Obviously, we'll go through how to get there. So what we want to do first right here is cross multiply. 2 dy, okay, equals, and then we're going to cross multiply again. We're going to x, y, dy. That is not good enough to integrate yet. We still have to separate these. We have to separate the x's and the y's with their dy's and dx's. So the x and the, so that's a dy, that should be a dx, I'm sorry. That looked ugly. The x and the dx are okay where they're at. The y needs to be moved over here. So all we're going to do to accomplish that is to just divide it. So we're going to write 2 over y dy. And we are going to leave, sorry about that, I really need to figure that out. And we are going to leave the, where is it? We're going to leave the x where it was. I'm going to write x dx. All right, so there we are. And now all we have to do to solve this equation is we have to integrate this. So all we're going to do is write integrals, or antiderivatives, if you will. Right, and from there, we just integrate. This integral is actually pretty easy. The 2 can be moved to the front of the integral because it's a constant, and we can write 2, and this will be the integral of 1 over y, and the integral of 1 over y is natural log of y. That was easy. We do an absolute value because we can only use positive numbers to take natural logs. And on the right side, same concept. We're going to do x squared over 2, or 1/2 x squared. The only difference is here we need a constant. We can't just leave that since we're integrating and it's an indefinite integral. We're going to have to do a plus c at the end. So right here is going to help us figure out what that plus c. We could plug in the 1 and the 1 right now if we really wanted to. It's not a big deal, but it's going to be better off for us if we get y equals by itself first. But it is an option to plug in the 1 now and then solve from there. So leave it up to you, but I'm going to go ahead and put it in and go for it. Or I'm going to solve it for y first. So solving this for y, we're going to divide by 2 right off the bat. Get natural log of y equals x squared over 4. And we don't actually divide the c by 2 because at the end of the day, it's still a constant. It's a different constant than the one above it, but we're going to find out what it is at the end anyway. So it's not necessary to keep dividing it by numbers. It's just going to make more work for us. And now what we do to get the y by itself, we're going to say e to this power, and we're going to get y equals, and we're going to get e to the other side, e to the x squared plus 4, x squared over 4. I'm going to do something a little bit shifty here, and instead of writing x squared over 4 plus c, I'm just going to separate it right now because we're going to use this in a second to e to the c power. Because basically if I ended up using laws of exponents, I would actually multiply these and keep the e and write x squared over 4 plus c as the exponent. I'm just kind of skipping that step, and I'm writing it like this because e to the c is just another constant. So we're going to write a big C in front of all of this. So we'll write C, replacing e to the c, times e to the x squared over 4. And believe it or not, we're almost done. And this is probably the hardest part of this problem. All right, cool. So what we really want to know is what that c value is. So that's where we're going to go back here, and we're going to use x is 1 and y is 1. And we are going to get 1 equals c e. When we put a 1 in for x, we're going to get 1/4 power. So to get rid of that, we're essentially going to divide both sides by e to the 1/4 power. And we're going to get c equals 1 over e to the 1/4 power, which sounds pretty crazy, but 1 over e to the 1/4 power is e to the negative 1/4. We'll figure it out in a second and see what we need to do with it. All right, so there's c. So now we go back to this part right here, and we write a final answer of y equals e to the negative 1/4. Then we write times, remember that's the c value. We're just rewriting this equation right here. We're writing that's c, and then times e to the x squared over 4. And now we have the same base, and we're simply going to take these. The 4 is the same denominator, so that's good. So we're going to add these exponents. We get negative 1 plus x squared, which at this point, I'd write it, but I'm just so slow at this, I'm just going to go and point to the answer. The answer is right there. Simplified. And we would put the 1.116 in for that x, and or I'm sorry, the 1.2 would go into that x, and we would get 1.116 for an answer. All right, so that's the answer right there. Cool, and now we'll talk about why they're different and if it's an over or underestimate. All right, last question here. It is an underestimate. I don't know if I had a picture of the slope field. I'll have to go back to the slope field. But if you look at the point 1.2, 1.1 in the original. So here's the slope field. 1.2 is like right there. I'm sorry, 1.2 is like over here. But you can see the slopes kind of, it's going from 0 to 1/2. So it's going to be something like that. But you can look at the overall shape of the graph right around here. It's a concave up graph. All right, so what that means is that when we're taking the tangents of it, they are going to lie underneath the curve. So we're talking about underestimates. So that's why this is an underestimate, because it's a U shape. And that's that. We'll do number 18 as well. I just don't have enough time for it on this video, so I'll stop this and do one more video.